Hey, Vijay.
Hey, everyone.
Okay, cool. Let's just review the subject. So last week we briefly discussed internally about this idea of having a more general timetabled receiver balance. I started with receiver, but there was some clarified points about should the sender be also the same. But I think generally the sender side is a bit more problematic. So since you are here and you are the one that actually asked for such thing, so maybe I think it would be good to get some of your input also. The short summary is that we could ship such feature even in V1 fairly easily as an extension, not even need to have a new CFA, but for the receiver side, it will be easier because of the solvency reason. So let me go from the beginning again. So the idea is that to have some sort of general construction of timetabled receiver balance, so that so let's say currently let's fix the sender side. Let's say assume that the first case, which is sender side, is the same for the constant flow, right? So your balance goes down constantly. This is T, which I didn't write. Right, so
just a quick question.
Ahead.
So is the sender streaming on a per second basis? Okay.
Yes. So we're assuming that the base case, so the base case we're all familiar with, which is the constant flow, both sides, right? So that's the base case in the upper column here. And so this is a constant flow rate, so a constant flow without any modification. What we could do is that we could, using a timetable general construction, that split the receiver flow into two different colors. One is a deposit, or not deposit, kind of withhold balance. So ideally, this should be taken out as a separate account from accounting concepts, right? So it'll be going up and down, like the zigzagging up and down. So that the green one, which is available balance, available to the receiver to be used in that sense, is zigzagging up with a timetabled cadence. And the receiver will be scalable per timetable, just like IDA per index scalable, right? So the scalability will be the same, while the sender side will be no difference. So that's kind of using timetable to have a general construction to split the straight line into a two separate lines. The green line will be available, the red line would be the withholding balance. Okay, and the one of the particular timetable is the monthly timetable. So that timetable can be recorded on chain very efficiently. So you can basically store the whole calendar, let's say, data points on chain through a either stored as a delegated contract externally at the external library, or even built in within the CFA, depending on what kind of optimization we're targeting. But I think that as external library probably is more organizational, code organizational wise, a bit more clean, while adding probably 100 or 50 gas cost. If anyone familiar with delegated core cost, maybe you can correct me, but I'm estimating around that ballpark of cost. So that's the receiver side timetable. Right, so let me make some text here. Oh, I have some chronicle text here. Is that understandable, Tony?
I believe so. So the sender is streaming in, and then there is some sort of escrow format, where essentially it's being withheld, but then this balance becomes available. How does this essentially withdrawing this balance, does this automatically show up in the real-time balance off, or is there a withdrawal function needed?
It is all scalable per timetable. So you can have a same timetable, which is monthly timetable, right? The very common timetable. Yeah. And everyone can have, so basically you don't need to do withdraw even. You just, in this case, you don't even need to do subscription like IDA do, because this timetable is global available, and extra subscription is unnecessary. So you basically just have it with you.
Yeah. Now, may I perhaps ask a little bit, when you say the word timetable, what exactly does that mean? Perhaps is a data structure, or what exactly does this look like?
So I think of a general term, right? So monthly is a timetable. So every month and end of month is a time point in the timetable. Okay. So you can think of timetable as just a sequence of time, the points of time in time. So with that construction, it's actually quite easy to model that. I wanted to actually create a specification level, a model of that, but I haven't got to that. But conceptually, I thought about it should be fairly easy. So any type of timetable could be modeled, including something that may need a subscription, which is the vesting timetable, right? So if some company decide to have a vesting that is not monthly cadence, but quarterly cadence or whatever weird financial accounting that their accountant convinced them that it's necessary, or the regulator convinced them it's necessary, then that timetable could be also implemented. But then the question is probably that timetable need to be subscribed per account basis, not globally subscribed like the monthly calendar.
Yeah. And just to clarify, this is an agreement per timetable. So if we want to monthly, it will be one agreement. If you want to do yearly, that'd be another one, or whatever.
It will be a feature of the same agreement, which is a constant flow agreement. It's just that the narrow case is there's no timetable, or the trivial timetable is lack of timetable, like what we have now. We're extending. We're doing extension to, like the ACL. We never create a new agreement. We add a new feature, and in this case, we're just adding a timetable support, and the monthly timetable happened to be the one that probably the most asked because of the legacy accounting implications.
I see what you're saying. Okay, very cool. Now, this is really, look, I can definitely see the use case in this. You're right, being able to essentially determine how the value is transferred on the receiver side. However, for the specific use case, I guess we have in mind, perhaps a little more selfishly, it's very much the idea that the receiver can have this step function. So the sender, sorry. The sender is not streaming in, but the sender has a step function. Is rather what we are, for the specific use case of subscriptions, this is perhaps what we would like. It's not actually that important if the receiver gets paid in streams, or if it gets paid on the step function. It's more about this on the sender side.
Yeah, so that's where I want to clarify with you a little bit more. So the reason that the design was not from sender side is because if you think about it, if the sender is a zigzagging, which is possible, actually, the timetable can be a construct that applied to both sender and receiver. The problem of this particular timetable on the sender side is that you would have a very fragile time point globally, that at month end there is a drop in many sender accounts. So that's not necessarily very desirable from the solvency perspective. And although I should also mention one thing, maybe that will make you think a little bit differently, that what happens if the sender cancels the stream in between, right? So let's say at this time point, right? What if the sender cancels in this time point as opposed to somewhere here or here, right? So the default behavior is that the sender get all the money back. So effectively, it is zigzagging. It just happened that some more money in the red line, but red line is not in the receiver side at all. It just happened to be a counting item that we can record it in the receiver side, but it's just recorded somewhere. There's no clear ownership yet until the timetable hits, right? So until timetable passed, until the time passed the point of a timetable, the red doesn't belong to anybody actually. Well, in the data model perspective, it may seem like it belongs to the receiver's balance, but it's not actually owned by it yet. It's still in a withholding period. So the default behavior is that if you cancel here, it goes back to the sender. So effectively, it is a zigzagging. It just happened that it has to be withheld. So that's the kind of behavior that, in a way, that is kind of easier for the solvency to handle because sender side is still effectively quite smooth. But the behavior here is up to the application actually to adjust. So I'm just wondering if that does make a difference to your user or not. I have a hard time to imagine why it doesn't make a difference, and if they can actually get the money back effectively zigzagging down anyway.
Yeah. So Miao, where we're coming it from is largely one where. So one of the main friction points we've had essentially when talking about streaming subscriptions specifically is that people are used to the idea of essentially consumers prepaying, at least for fixed price subscriptions. So businesses, the value transfers at the beginning of the period, they prepay, and then the business delivers the service to them. Cool. Now, okay, we can make arguments that parts of this is archaic, etc. But this is how the value transfer largely works. It's pre, and then you front the service. With streaming, you're largely continuously delivering the service as value is transferred. So as long as the value metric, which is, let's say, time, is tightly coupled with the value you deliver, it works very, very nicely. But the issue is, let's say, when time is not that tightly coupled with the service you're actually delivering. So imagine if you are a business and kind of, you're not really selling access across periods of time. Maybe you're selling RPC calls. Who knows? You have $50 a month for RPC providers. In that case, largely the way these businesses are thinking about it is we have a fixed cost for a consumer, which is $50 per month. And what we don't want is a consumer to be able to only pay $22.75, you see, and then jump out. So it's more about, the friction is more about the idea that the user can come and go as we are delivering the service. Sorry. Regarding this question, prepay the first month. That can mitigate some part of it essentially. That yes, you can do a batch call with a transfer for the first month, and yes, it may mitigate some of it. However, you still have that, because thinking from a psychological perspective, if you're a consumer and you're really using the value transfer like that, you're going to get rid of a lot of the bad actors by not who don't prepay. But there is still this like feature or bug, whatever you may call it. It's baked into the way the money is moving.
So what I would suggest, I think last time we also mentioned, but since you're here, it's better that you could. So with this construction, it doesn't care like how you actually do that business logic part, and it should enable several different type of business logic. Let's just ignore this one first because that's where the contention is. Let's think it for now, which I can't. Whatever. All right, if you can just ignore it for now. So yeah, one type of combination you could do is that you get people to do the prepayment through batch call, for example, and then stream like this. But the user should be aware that until the monthly end, the streamed out amount you may still get back from the business if they think that well, it seems they prepaid 1 month already. So I think it is fair that they could just get it back. It's just that if they cancel in between, they just get get not only the red number out, but also back, but also maybe partially the prepaid amount, right? So let's say they prepaid a month, and they cancel it in the middle of the month. They not only get the red part out, but also the prepaid some part out. But that depends on the business logic, right? It's not really protocol's job anymore to decide what's your refund policies. Maybe you decide no refund, which is reasonable. I mean, quite many businesses don't do refund if you only use 20 days. I mean, most people don't even cancel. You only cancel. Okay, they cancel, but they just remove the account. Maybe from the next month they just lose the service, right? So I would still argue that prepayment plus a smooth line and the capability of being able to get a refund in the middle of the timetable is still a workable solution, and that's good for better for the system in terms of solvency. And we're talking about subscription in tune of maybe a sub 100 type of thing for the sender side, right? So I'm just thinking if creating this kind of systemic trouble for the solvency perspective is worth it versus having this setup, if that's understandable.
Yeah, I mean, yeah, look, I see the solvency issue. Me and Fran, we talked about this a little briefly as well. Well, look, I do see the point of having, let's say, one period within the timetable or one specific given point, let's say the first day of the month, where all this value is supposed to move. This creates massive systemic risk. Yeah, I do actually see that, and I perhaps a little more objectively saying, I'm not sure. Yeah, it's a little bit tricky. I kind of specifically to implement that right now. I see why that could be tricky. Because within the protocol, I mean, I know there are many higher priority items. Yeah, but yeah, perhaps I know there may be other use cases here, specifically for what you've just described, where the receiver receives as a step function. But perhaps to be quite transparent, I'm not sure this wouldn't solve what we're looking for. This may solve a use case for payroll, where it may simplify the process for businesses. Because one of the issues with payroll is these accounting firms don't know how to make sense of people getting paid every second. But if you allow people to get paid on a periodic basis that accounting firms can understand more reasonably, I think this could really unlock that use case, but it's not going to unlock our use case.
Okay. Specifically, you think that it's still better for the sender side to not even taking out the money in a smooth way, but I mean,
in a step function, yeah.
But as I said, it's just a matter of those money is temporarily held somewhere until the month end. They are not taken away, right?
But the thing
that's
is,
still my point.
Yeah, and what I'm trying to say is that we would want the money to be taken away. Like we want essentially we want the money to move. The business wants to get paid up front, and then they want to deliver the service.
But they get them paid up front 1 month.
With batch call, but what happens month 2?
Month 2 is already the green one already taken out, right? So the green one mean that the money is transferred to business already at this particular time point. Okay, let me maybe write the example out. If that's so, because I'm not so sure that I got.
I hope maybe I'm not understanding it correctly here, but you think with the batch. So batch call fronts essentially 1 month, and then because the stream moves like this, maybe you've moved up the time horizon.
So let's say examples of such that it's about when sender cancels the stream, right? Let's write a couple of examples.
Yeah.
Okay. So what first base case is that base setup is that there is 1 month of prepayment, right? So let's just make that as part of the example. So you do ask for the user 1 month of prepayment. So on the day 1, if they cancel, right? If the receiver cancel, let's make it a number more or less abstract. I have a tendency to make it too abstract, so let's make it so let's say $10 per month. I don't want to use $9.99, okay? Just $10 per month. Right? So let's use this number. So from day 1, at day 1, if the sender cancels it, so $10 goes to the receiver.
Yeah.
Right. So that's already clear. On day 15, still $10 goes to the receiver. But at day 31st, let's say 30 days per month for simplicity. Right, in all cases. So at day 31, what happens is that now $20 goes to the receiver. Right.
Okay. Yeah, because you're double paying. Okay, I see. Yeah.
Yeah. So what happens is, okay, which I should specify a bit more, that sender balance is, okay, sender gets 30 cents, roughly 33 cents dollar refund also, right? So because it's a smooth stream, 30 cents already, 33 cents already went to the receiver, but in the withholding account, so it's in the red part. But at day 1, he cancels, 33 goes back automatically to sender, right? So in the second case, sender gets $5 refund, right?
Yeah.
So at day 31, same thing for the receiver, right? So it's 33 cents. So that's a construction that I'm trying to convince you that it should be. Yeah.
Thank you for that. Sorry, Mel. I was not understanding that correctly. Okay.
No worries. I do have a tendency to make it too abstract for me to. I think in numbers may be easier to understand. But conceptually, yes, the timetable is a generic construction. It's not fixed for the monthly table. And the green one is the one that the receiver actually sees the available balance going zigzag up. And the red one is the one that going this kind of curve that
I see.
Yeah.
Okay, actually this works pretty nicely. The batch call really gives you, from the business's side. Yeah. You just, by including the prepayment, you essentially move the period up 1, so everything slides up.
Yeah, you do a shifting 1 month period. Yes.
Yeah, you shift 1 pretty much.
Yeah. One thing, okay, but one thing I do want to ask though is, I mean, I still find this bit funny, hilarious. Sometimes I even think about it, but there's a monthly difference, right? 30 days, 31st, 31 days, 28 days, this kind of thing. Is that any deal breaker for people? It doesn't matter. In your case, have you poked around with that?
Yes, the 30, 31, 28 sometimes in February. No, not a deal breaker.
Okay.
Yeah.
That's good. I mean, I can think of some more peculiar way of fixing it in the timetable, but I went a bit too far. I mean, even timetable itself, I think it's a fix for the legacy thinking, but we can make it happen. It's not too bad of fix at all. It's a good generalization, and it may also work nicely for the vesting also. But 30 and 31 days is a bit too made up. Let's say the way that it's trying to fix a problem. So that's still possible to fix, but it's getting uglier with that. So if that's not a problem, that's good here. And yeah, that's about the timetable thing. Okay, no, you want to say something?
Yeah, no, it's possible to use the timetable, for example, instead of using batch calls to pre-transfer the month, lock it inside the deposit. So the receiver knows it's going to get the first month independent of what's going to happen.
Yeah,
But don't send.
I would prefer the primitives in the protocol simple than if it can be composed built on top of the protocol, things like batch call plus this simple timetable, and then it would be preferable than build a very specific case just for that in the protocol, right? So if we can already achieve it by combining batch call plus the general monthly timetable, and that's I mean the basic thinking is that if it can be composed, let's compose instead of building something extra in the.
Now, couldn't we, like, if Tony thinks this is okay, couldn't you resolve this without building an agreement and simply making the timetable an app?
We talked about last time, but now we can record it live. Is that the composability? You can't get those money out. The good thing about the global timetable that everyone subscribes to implicitly is that if you have multiple as a receiver, if you receive multiples from multiple senders, let's see. If it's same app, yes. But if it's not same app, let's say if I'm the receiver that I have different applications, that do create a, let's say if you have several super apps that has same monthly table, then they kind of compose, right? So if you are talking about just one super app that the receiver use for all the monthly receiving, yeah, then okay, wait, then also the composability regarding being able to withdraw the green part, right? So with a timetable, it's automatic goes to your receiver's available balance. Without it, it is claimable only.
Yeah.
Yeah. So it's all about composability.
Now, how many timetable periods? So how generalized was this get? So monthly, yearly, daily, hourly, every 27 seconds. How does how should I think about this? Will it be a preset range, or is this sufficiently general, essentially, for any timetable?
The more data points you have, the more inefficient it gets, right? So I think monthly is in general okay, because let's think of 30 years is the mark. Then you have only like 360 data points that you need to implement in the external library, which with a bit more optimization is fairly efficient to be referred to by the CFA extension. We could even optimize it as an internal function. I mean, if the CFA contract size allows, but generally speaking, if it's external timetable library, the less data points, the more efficient. The more data points, the less efficient. But I can't quantify it. I haven't do the prototype, but
yeah,
from monthly perspective, it's fairly efficient. Yeah, 30 years, 360 points. So it's really, really manageable. If you're talking about a vesting case, like quarterly vesting, this kind of common practice in the corporate, right? So that's even easier, less data points. However, the problem is that those are usually not as composable as monthly, but quarterly can be another different timetable maybe, can be built in, supported.
I think monthly and I guess yearly, specifically in our use case, will cover almost everything, like 95%. Yeah.
We could basically have yearly, monthly, and the quarterly table built in. You know, that's kind of the most common use cases. If it's weekly, then we get a little bit more tricky territory. Still manageable in my estimation. But actually, weekly is probably even easier to model because weekly is 7 days. The same. We'll forget about the what's it called? The year that has one more day. How do you call that?
Leap year.
A leap year. So forget about leap second thing. Then the weekly is actually easier to implement because it's not the arbitrary data points you need to record, but just a simple function to know which week is it, right? Forget about the 1 second, the leap second half thing in accuracy, but otherwise it's quite accurate. So weekly is actually even simpler. It's a function instead of data points. Monthly, unfortunately, is data points because of the 30, 31 day, these kind of differences. Same to the yearly table.
Okay, thank you for this, Meow. Thank you for explaining this. Look, this is I'll need to think about this a little bit some more, but I think you're right. This actually does cover it largely because you shift it up by everything. Yeah, I think this.
Yeah, good to hear. I'll paste this text so that you have a reference to you. Yeah, you can refer to just a simple example. Yeah, I could do a specification level of try. I mean, I wanted to do last week, but didn't. But I'll get to that, and then I can say 100%. At the moment, I'm now 99% sure that it's not a problem. If I have the spec, that I can tell you 100% what's the data model and how easy to if it's possible. If it's possible, then the implementation is also fairly trivial. So
the nice thing, sorry, on the solvency side, there's no change needed on the sentinels because it's just CFA solvency.
Exactly. That's why I want to convince you that this is actually works. This works for you.
Fair enough.
Good stuff. Okay. If it works for you, give us some incentive to actually make it happen faster. Also, I'll let you know.
For sure. Thanks, man.
All right. So the next subject is the constant flow distribution agreement data model. How it works. Okay, which one should I show? Easier. Let's try. It's a bit turning head around. So let's see if we can get this clearer. GDA, we've been talking about it, but I now finally spec it out. I think it is. I tested already with the CFDA, so it works wonderfully. With also the property of the precision loss taken into account. So it does introduce precision loss, at least with the data model I did, but I haven't tried the Ethereum floating point fixed point yet, so I don't know that yet. I'll test at some point, but likelihood is that it would introduce some. Actually, maybe not. I'm speaking too early about it. I will see. It may introduce, may not. Precision loss in using fixed points, but the idea is that the current thinking that I have so far, I believe that the distribution curve is generic. That it doesn't have to be constant flow or any type of. It can be any curve, so long as there is a continuous. Continuous meaning that it is how do I explain continuous? It is smooth over time, so it doesn't have any abrupt turning points or something. I can't remember what's the proper definition of smooth anymore, but I hope it's understandable. So analogy-wise, it's basically smooth, right? So what's not smooth? Actually, IDA is not smooth because IDA is exactly up. So, but luckily, IDA is a special case that it didn't need the smoothness property, and it can be implemented well, which is the first one we implemented, right? So, but generally speaking, the idea of the generalized distribution is that this distribution curve, it is entirely can be entirely arbitrary, but has to be smooth. However, ideally for the system that it should monotonically going up only, because if it goes down at some point, it's not good, right? So for the solvency perspective in terms of distribution, if it goes up like a constant flow, it is always better. CFDA different to GDA, yeah. So CFDA is one case of GDA, let's say. No, your laugh is recorded online, so it's okay. If it, GDA is about any type of distribution curve, right? So for example, a hypothetical case would be, I would use that case, but just for the sake of a different example than constant flow, is a decaying flow, right? So decaying flow can be a curve that you can also do this kind of distribution. Over time. Proportional distribution. Actually, when we say distribution agreement, it is a shorthand for proportional distribution. There can be other type of distribution also. On a side note.
So yeah, sorry. This is still if we mind, this is still one-to-many distribution, right? This is so in IDA we have one-to-many or just discrete units. Here we have one-to-many with flow or any other or constant flow or potentially quadratic. Is that what that's what's happening?
Yeah. Yes. Sorry. I got distracted. So what are you asking that? So can you ask it again?
So I just want to clarify. GDA one-to-many distribution, but the way the value moves can have different types of instances. For example, the constant flow distribution. It can like one-to-many move every second, and then we have one-to-many move on quadratic.
Quadratic one is set aside. I can briefly mention after this, but GDA here mentioned per se, it's actually a proportional distribution generalized for any curve.
Very nice. Okay.
Yeah, so IDA is a special case, which is not actually a smooth curve, but because it's special and it can be optimized out to the curve part, then it actually works without being smooth. But in any other case, it has to be a smooth function. A constant flow is a smooth function, so it's a linear over time, growing over time. So it is smooth. Decaying flow is also smooth. So actually decaying flow can be also distributed one-to-many. Other curve can also. The other one is a quadratic distribution, but quadratic distribution is a setup that a bit peculiar because it's not about the quadraticness, but also about the. Let me just show, right? So this is founder, and the initial founder. Let me just run a quick tangent here. So initial founder decides, right? So the whole point is that it contributes to this quadratic distribution index, right? So there is, let's say, 10,000 per month contribution. And in this one, there is a selection of competitors, let's say 10, let's say 100, attendees, or how do you say, 100 projects. That's how it works. So when this index is setting up, all 100 projects receive 10,000 per month in the same amount. So divide 100 equally, right? And then what happens with the matcher? So initial founder is also called the one that does match, right? So the if you think about that, that's how basically the Gitcoin worked, right? So the matcher would found something, but in this case, it's smooth, right? We're talking about constant flow type of thing we can do. So when the voter voting with money come in and vote for one of the projects using strings, and then the distribution between 100 projects start to quadratically change. That's how it works. So if you as a voter contribute 10 per dollar to one of the projects, your voting influence is much larger than the proportional sense. That's why it's quadratic. So you don't have to have a lot of money to influence the amount of money from the initial founder going to one of those projects. So that's if you look how the Gitcoin works, that's basically how it works. Right? So basically, the voter can influence the amount of money the initial founder is giving to those 100 projects. The split will be quadratically determined. That's the sense. So it can't be emulated using IDA because of that. So it is a setup that needs an initial founder. So in this case, there are 3 participants now, right? 3 classes of participants. In the IDA case, sorry, in the GDA case, there is a publisher and a subscriber. In the QD, in the quadratic distribution index, there are 3 types of participants. The matcher, the initial founder, that's one class. Then you have projects, there's a different class, and then you have the voter. So there are 3 different type of actors. So that's why it's not emulatable through the IDA. So that's why it has to be a different construction. So it's GDA, sorry. But that's just running on a tangent here. So let me save that. That's the QDI index. Have you participated in anyone has anyone participated in Bitcoin? Knowing how it works?
I haven't participated, but I know how the math works. So yeah.
Yeah, so if you think about it, I mean, if you have a QD IDX who can basically using stream as founder instead of, so basically you are constantly influence the stream going to the any number of projects, right? So it's a 3-actor kind of agreement system. It's I would say super cool, but we have a lot of cool stuff. And it's real-time balance, so that's a cool part, composable part. All right, so let's say one example is 10 per month, and this guy has like, and they're influenced quadratically, right? So that $100 influence is not as much as, so that would be like a square root of 10. That would be like 3.3 influence, while the 100 is 10, right? So while the amount is 10 times, but the influence is only 3 times more. So I think that's basic math here with a voting power. And initial founder doesn't care. Initial founder is just trying to ask people to vote to which of those projects, how much they receive. But quadratically determine their influences. Yeah. Okay, so now we'll come back to this one. Right. Okay, I think the most important principle is all of them are important, but the first one is that okay, wait, maybe let's go to the idea how it works. Maybe even that one is not super clear to some people. The important data piece is one is called a value per unit, and one is called a settled value per unit. So I'm using VPU and SVPU just to distinguish them as shorthands later. All right, so from the publisher side, pub, there is a value per unit. That's basically how IDA is recording all the changes over time, and IDA distribute value always goes up, right? So that makes it also easier to reason. I mean, mathematically, the specification doesn't care. Actually, it tested all cases, including going down, but practical implementation-wise, we only want the distribution value goes up. Otherwise, you allow the IDA publisher to rug pull its subscriber, right? So that's probably not nice. So each time you do a distribute value as a publisher, the curve goes up because the value per unit goes up by the amount of value you distributed divided by total unit. Let me write it down here. So this amount is the delta of the VPU let's say VPU. Yeah, VPU delta equal to distributed value divided by total units. Right. And right here also. Distribute value. The other is TU is total units. Right. So that's what happens when the publisher do a distribute value. But let's go back to actually the first step when the subscriber subscribe to the pub. What happens is that the red curve goes up, so you're tracking the settled VPO, right? So there's always a settle function, which is important. You always settle to track the VPO. So at the moment of settlement of subscription, sorry, the difference between VPU and SVPU is 0, and no matter how many units you have, the amount of money goes to your account is always 0. Right, so that's how the idea works. But next time when the publisher goes up to the distribution, right? Yeah, when the publisher distribute value, then the VPO goes up. So the delta between VPO and SVPO become this gap. And that's where the money goes to the subscriber, right? So subscriber one. So basically that's all it's needed. So the difference between VPO and SVPO goes to the subscriber. That's how it works with IDA, right? So that's a general idea. But taking this idea further is still using the VPU and SVPU, but with a curve in between. So that's where the magic needs to be happening. It's about how to reconcile the fact that the curve is a smooth function of time, and the principle is that each time you do an action, things like subscribing to units, things like distribute flow, all these are an action in this GDA, particular type of GDA, right? So excluding IDA. So you have to do settlement each time any of this happens. So there's different way of how to do settlement. So I'm using something I calling stick arithmetic. So that's basically you calculate the value of different sticks here, and now you have 3 sticks. They all have a formula, and then you do some plus minus according to the direction. Then you get this final stick, which is the settlement value. So that's all it's needed. I don't know if I can go to the details too much, but that's a general idea. So the principle, let me go through again. So the principle is that the publisher's VPO is always updated for either a publish operation, including distribute flow, distribute value, or update constant flow. Sorry, update constant distribution flow. So it rhymes with update flow, right? Update flow is about one-to-one flow. Update constant distribution flow is about update a constant distribution flow, or a subscriber operation, which is update subscription, which is update the number of units. So all these would trigger a settlement operation to change the value of VPO. In the case of a subscriber operation, it also updated the SVPO, right? So because it's not only publisher got influence, but also that particular subscriber. So that's the general principle. The detail, devil's in the detail, but it's in spec. I'll show you in a minute. Another key point is the publisher's balance curve is indistinguishable between sending to one participants versus sending to n subscribers, which is a nice property. So basically, for subscriber, it doesn't matter. You are splitting the stream between one or just or between n. So it's a nice property to have. So that gives rise to how to implement it efficiently, but I'll not go to the nitty-gritty here. It's something called length abstraction. The third observation is that a subscriber's set SVPO, the settled value per unit, is updated only when a subscriber operation applied to it. This is what makes it makes it scalable, right? So the last thing you want is that if you want to update a subscriber and all the subscribers needs to be updated, it's not scalable. But in this case, you only update 2 data structure with data piece. One is the publisher's data, and one is this particular subscriber data, no matter how many subscribers you have. So that's what makes it scalable. So with 3 principles, you can effectively implement any type of a distribution curve. And so far, our example are only constant flow and decaying flow, right? So, but in principle, any type of curve between 1-to-1, you can use this principle to split it between 1 to n proportionally. And with the introduction of QD index, you have the same constant flow, same decaying flow. You can re-implement, recast everything almost in a very reusable way to different index. So that's where the concept of index coming from spec perspective. Something called universal index is the one that make CFA and ITA, which is an exotic concept, never need to be implemented in the EVM case, because in EVM our ITA is handled by ERC20 interface, so it's not unified under the agreement agreement framework, right? But conceptually, it's just another type of agreement. It happens to does instance transfer, and there's nothing ongoing in terms of contract. So it's a null contract. That's called a universal index. Universal literally means universally available for everyone without needing to subscribe to it. In that sense. Another thing is called a proportional distribution index. So it is using the same instant value or constant flow formula, but cast through the lens to different instances. In this case, you make the instant value cast into a IDA publisher and IDA subscriber, right? With constant flow, you cast into a CFDA publisher and CFDA subscriber. Same thing with the decaying flow, you can use the same pattern, cast everything into publisher and subscriber. And same goes with QD index, fairly similar construction, but now with 3 actors. That is the projects, the founder, the matcher, and the voter. Yeah, it's just quite natural. But with this particular length abstraction, you can basically cast the same thing into different use cases, right? Universally indexed, proportional distribution indexed, and the quadratic distribution indexed. Yeah, that's. I don't know. I mean, the details probably harder to explain. I don't know what's the format, best format. To actually go to the details. But I can describe some properties if no one has more specific question. Yeah.
Sorry, Mel. I just have a question regarding, so will there still be a 256 limit on the number of indexes you can subscribe to for each of these agreements?
Yeah, that limit will stay, unfortunately.
That's okay. But that will be per agreement though. So 256 per constant flow distribution, 256 per IDA, 256 per quadratic.
All right.
Right?
It's up to the implementation really, but it's fairly arbitrary number, to be honest. Actually, if you make them, okay, wait. First thing, the indexes is probably preferably shared between CFDA and the IDA. So same index. At least in the specification, it's written in a way that you are subscribing to the same index, but the index can be used either for instantly distributing and or the constant. So it's the same index, but you can apply different functions. One is instant distribute some value, and one is constantly, right? So they're actually quite flexible in a way that if you have a particular use case that there is a base constant flow, but sometimes you have some kind of ad hoc or erratic, I don't know what's the word for it, non-predictable instant distribution for whatever reason, right? So then you have a base constant flow to everyone. Then maybe in Christmas you give everyone some money, or in whatever festival you're talking about, right? So that's kind of then you don't have to have 2 index, it's just same index with all the functionalities. You can even have a decaying flow maybe someday. I always bring up decaying flow just to make it a more interesting, that not just constant flow, but still no.
What about FFT flow?
Yeah, we'll talk about it, but I don't know. Maybe, yeah, generalized curve, yeah, arbitrary curve. Yeah. Practically, I think the both the monthly and the CFDA, or I mean CFDA probably needs a little bit of refactoring in our. Yeah, we're not so sure the implementation plan yet, but there certainly is some something that we talked too often that maybe someday we should just make it happen. But now we have data model, so I'm fairly confident that if we decide to work on it, as long as we can refactor a little bit of code, we can get it in, because there's no pending issue to be addressed in terms of formula and data flow, data model.
Very cool.
Yeah. Maybe I can just show one thing, which is the precision issue, which I still haven't think deeply about it. I'll just show you the precision property that so far, what's the problem? Wait, where the file is? Over here. So I tried to make it close to EVM scenario, but I unfortunately accidentally used a double type, so that's where the precision issue kicking. But in EVM, it's not a floating point, so it's a fixed point. So actually model it differently. But in general, what's happening here is that the base fixed point base is 18 decimals, like in EVM. And the flow rate base for testing purpose, I make it a multiplier of integer multiplier of $1 per month, just for the sake of easier to understand in human minds. Right, so $1 per month is a base. The other is the tolerance. So the property is that the most important property of superfluid agreement is that the sum of balance should be 0. Right, so let me show the general. What we want to achieve is this golden property of always equal to 0. Whatever operation you do, the balance of sender, receiver, publisher, subscriber, founder, matcher, voter, and projects, they add up to 0. So that's the golden property that we always want to adhere to. However, because of the floating point, it's never possible. I still don't know if the fixed point can help. I need some help with. I'm getting some help with that. But with that imprecision, so in the test case, what I have, the fuzzing test case, is that it has 4 decimals of inaccuracy up to, right? So the fuzzing is like it has 1,000 or 10,000 test cases that randomize all the CFD operations. It does subscription, distribution randomly between 1 publisher and 2 subscribers, or 2 publisher, 1 subscriber, 2 different base case, and randomize whatever operation. And with many fuzzing, the accuracy I have found so far is the sum of balance will not be strictly speaking 0, but the inaccuracy is limited to 4 decimals of $1. So that means around 0.001 with 3 accounts, right? So you can imagine that perhaps in a larger sample, you would have this kind of small errors accumulating over time. Still fairly small in fairness, because we're talking about $1 a month, but the accuracy is not per month per se. Yeah, so it's actually just 4 decimals of $1 of errors after arbitrary number of operation and time ongoing. So that's currently the accuracy with this particular fuzzing setup, and the maximum flow rate was 100 million in the test case per month, and in IDA there's no dust case, because it's specifically handled in a way that the publisher would factor in the accuracy. So actually it's kind of handled nicely. So in IDA case, it's always accurate to 0. So that's property holds. So in CFDA, so this is one of the pending issue that needs to be addressed, but my instinct has been telling me that it's actually okay. But if we don't use double, and in fact we don't use double in EVM, so perhaps we can fix it. But at the moment, I don't have foolproof answer to that. but so far it doesn't seem to be a big issue either.
Sorry, Miao, could you go over the accuracy point again, maybe with an example, just so I understand?
Okay, so the let me rephrase a bit more. So the test case is done in a way that the flow rate is randomized between 1 to 100 million per month. Think of in dollar term. It doesn't matter. The unit is doesn't matter. So between 1 and 100 million, that's a randomized flow rate in test cases. And the other thing is that the test cases are randomized with the arbitrary number of operations. Sequence can be 100 operations, can be 1,000 operations, separated apart by a randomized time points, which is there's no bound actually for how far apart the time is either. I think I can't remember. Yeah, I don't think that might. Wait, let me check if I could. Timestamp, right? Yeah, there's no particular way how to randomize the timestamp, so it's arbitrary. Actually, in the test case, it's even back and forth, so it's can be time forward, can be time backward. That didn't matter. Maybe I can fix that. Maybe that one. I don't think it's wrong, but so randomize operations. So randomize, let's say 0 operations or 100 operation or 1,000 operation, doesn't matter. It's all randomized, and flow rate between 1 to 100 million, but without the decimal. So it's never going to be 1.1 or 1.01 or integers to make it simpler. After all the randomized operation, then you calculate what's the discrepancy between the sum of balances. Ideally, the golden property is 0, right? So some are negative, some are positive, just for test purpose. We don't care about solvency here. But the observation is that there are up to 0.001 accuracy in dollar plus generated in the end through 1,000 random cases, or up to 10,000 I even tested. So between 1 publisher, 2 subscribers, or 2 publisher, 1 subscriber. I think it's probably both linear to number of participants and the time period, the inaccuracy. But as I said, the inaccuracy doesn't seem to be too big, and probably fixable using fixed point number instead of floating point. So, but I don't have clear understanding yet. Maybe I'll figure out at some point after I talk to somebody. Yeah, so maybe I can talk about just data piece. What are the data we need to store, right? Let me find the diagram that maybe to illustrate. In case of IDA, we store for publisher, we store some data, right? So forget about actual term, I'm not gonna spell it. So publisher, you need to store some data. For the subscriber, you also need to store data. It's called a contract, and publisher, just data. So we store both. And if you look at the specification of that, I think that is fairly familiar to you, Vincent, at least. You're familiar with it. So publisher side, we store settled value. I can't remember how we named it in the code. And subscriber side, sorry, publisher, we need to store two pieces of data. One is BPU, value per unit. Let's compare side by side, actually. I was hoping the search engine can find the file for me. So let's do a one-to-one mapping to the IDA implementation and the spec level. And then we'll see the constant flow agreement. Nice. Should be clear. Okay, so in IDA, how do we? What I'm seeing? Wait. Wrong. Yes, sorry. This one. Right. So index data. Right. What the hell is that? So that's the index value is the value per unit, right? It is the index, the value of the index, or value per unit. Actually, I need to install get the proportion of base data common. So there's some common data that's shared between IDA and CFDA, right? So in terms of publisher, you also need to have a total units here, right? So, but in the spec, there's no approval nonsense. It will be modeled the next level, not in the approval, not in the base spec. So this adding together basically is a total unit, right? Yeah, that covers the publisher side, right? It's named differently and structured differently, but essentially the same thing. In terms of subscriber, sub ID is more specific implementation detail. Index ID and publisher is also implementation detail. So this one is for you to find the reference, right? So all these are a bit more implementation details. That's why it's not mentioned here. But actually, what's important to the formula is the index value, which is wrongly named. Again, it should be called settled value per unit, right? So this actually is a copy of the certain index value at a certain point of time. So it's more like settled index value, right? So in the spec, it's called more clearly, it's called settled value per unit. Then you have also in the base case, you have to base data structure. You say as a subscriber, you say how many units I own, right? Settled at is not modeled because it's IDA. It's optimized out. In IDA, you don't need to have the time for calculation apart from remember it, but it doesn't have any actual usage in IDA because time is not important, right? So, but in the CFA, this is actually used. So for the subscription, there's two common data. One is owned unit, and one is settled time. And that covers it, right?
What's the settled value?
That's the index value here.
I thought that was the value per unit.
Oh, settled value. Settled value is the one that we have this optimization for in the token, the settled value. it's all shared, right? The same thing. So it's not reflected here, but it's one value stored for all agreements. But in this case, it's modeled separate value. But the implementation is optimization of this, so it's settled value or shared between agreements. But in this case, it's singled out. Okay, so the settlement, you can ignore all the syntactic noise, but I believe you can understand just all IDA does is just one simple thing, right? Each time you do a, don't be intimidated by this. It doesn't matter really. The only thing that matters is the formula of, if I can find it. Settle, it's called settle. Remember that I said that all the GDA instances need to have a settle function. So that's where the settlement is done, right? So that's basically, yeah, that's it. The settlement is basically, you calculate the delta of settled value, right? That means when you do a settlement, you see what's the difference between VPU and SVPU multiplied by the number of units you have in your account. And that's a delta. You record the delta to your settled value and remember the new VPU down. That's two formulas. So that's basically essentially we do the same thing in the implementation, right? So as simple as three formulas separated. So that's how you do a settlement for the IDA. Okay, so you can take a quick look, 6 minutes of CFA. Maybe too fast to look into it, but why not? Constant flow, constant flow distribution agreement data structure. Okay, so this one is getting slightly more involved, right? So because now we deal with the flow. So for the distribution perspective, the base one is still how many total units? Total units. Jesus, what kind of spelling? Okay, I'll fix it. DC distribution count updated at, well, we need to remember time now, right? In the IDA case, we don't even remember when it's updated because it was not used in any formula, so it was ignored. But we need to also remember, or we do need to remember what's the flow rate of this distribution. So that's a kind of big pipe, total flow rate of this publisher. And there's also the value per unit, same as IDA, right? You need to remember the value per unit at that particular moment. Yes, this one. Oops. But this value per unit comes with a caveat now because it changes over time, right? So that's where I wanted to show this particular curve. Right, so while the value per unit is recorded in discrete value, but the curve always moves, right? So you kind of have to, I use dash line because it's not actually settled on chain, it's just something that you have to track over time. The moment you need to track is when there's action. It's like the basic principle of Superfluid. You don't do anything on chain unless there is an event happening. That's a basic principle. But underlying there is a curve. You just don't do anything about it when there is an event. The event or either a unit subscription happens or either a distribution flow happens, right? So each time that happens, you move the settled value, the VPU, right? Value per unit, you change the value, but you have to now track this. So for the publisher, the tracking is quite straightforward. You just track what is the current value, right? In fact, I should probably, yeah, this is a bit inaccurate, unfortunately. It's probably like this. Yes, that should be like this. So when subscribe unit happens, the BPU jump to the correct value, the underlying distribution curve, right? So it goes to the correct points. You track the current value. The next time distribution flow happens, you track the value again. But this time it's changing distribution flow. Before it was 1x, now it goes 3x. The speed goes 3 times faster to everyone, right? So that's where the curve also changes, right? But this green line is a DC value per unit, BPU. It's basically tracking this line over time, but each time only track when there's an event happens. And the basic principle, as I mentioned in this principle 1, is that whatever happens, either publisher side or subscriber side, publishers VPU always need to resettle and track the number. So publisher side of tracking is actually not that difficult, right? It's just tracking the current curve value. The receiver side is a bit more involved, and then they involve this bar stick arithmetic, I call it. So basically, you need to have a calculation of 3 separate values and add them together with a particular sign, right? Then you get this green stick, right? So green stick is telling you at this particular time how much distribution has gone through to this particular subscriber. The detailed calculation, I don't think I can go over it in a few minutes, but I'll just show you how actually simple from the spec perspective is. Basically 3 formulas. Right, I don't need to do anything more than that from spec perspective. Right, so it's basically I calculate the 3 bar sticks. One is the compensation delta. I think it's this one, because we need to take into account things happened before this event 2, because subscriber may not do anything before the event 2, right? So it has some compensation delta, and compensation delta divided by total units become per unit instead of total, and then do a settlement. So SV is a settled value. So basically in this case, move the red line for the subscriber. So you move somewhere, track the time points, right? So we're talking about only the first event involves SCDPU of the subscriber 1. Second event is distribute flow. Second event doesn't matter to the subscriber in its data, and it shouldn't matter to the publisher, because publisher wouldn't want to update all the subscribers, otherwise it's unscalable. So publisher simply say, I'm updating my curve, and all the subscribers' curve get automatically adjusted because of the calculation here. Then that's it. And if you go to the detail and understand why these curves needed, then that's what you are going to basically the detail of how to implement it. But it's not very intimidating at all if you see only 3 formula needed. You just need the right data structure and the right formula, and done. I mean, that's a CFDA for you, right? So about the data structure and the formula and the testing, right? So once you implement, you test that with the randomized operations, value add up together is 0 or close to 0, then you know that the implementation is correct. So yeah, it's okay. Here I need to mention one thing: how to know that the implementation is correct. I think then we can close the call. Is through inductive proof, informal proof. It's not formal proof. Hopefully someone do the formal proof for me at some point. But the informal proof is that you have one pub, two sub, from his leg. Okay, so that's one base case. So one publisher going to 2 different subscriber, right? Okay, now we inverse it. inverse arrow. Now we have 2 pub with 1 subscriber. Okay, so now we have 2 base cases. And the inductive reasoning means that these are 2 independent test cases, and plus 1 more law, which I emphasized many times, but it's probably hard to grasp, is the fact that the publisher itself, the publisher's data itself is a semi-group, or using simpler word, can be combined. So with 3 cases, pub data is composable informally or a semi-group. Then with 3 things together, then you basically inductively prove all the cases. So in the test case, you only need to test this case, and prove this case, not prove, but fuzzing this case. Then you basically informally, I claim that some people might correct me at some point, but I claim that this should be enough for base case for all the cases. So no matter how many publisher, no matter how many subscriber, the system works. If you tested that this rule or this equal to 0 always satisfies, right? So then inductively you say that all of the case would result in the rule of everything equal to 0. Then you have basically proved that the informally proved that GDA works, CFDA works in this case, right? Yeah, that's it. How to prove it inductively. For GDA. It's applied both for IDA and CFDA. There's no difference because we're talking about just publisher subscriber perspective. Right, so these are base case. Yeah, actually I wrote a Medium article, but I meant for me more of a notes, so probably not very easy to read, but at some point I will organize all my notes, then become probably more reasonable to follow, but I'll post the link anyway here. All right. Thanks for listening.
Thanks.
Right. Cheers.